A. Show that the volume of a metal sphere of radius 15 centimeters is 14,140 centimeters cubed, correct to 4 significant figures. The question already gave us the formula for the volume of the sphere, so all we need to do is substitute the r, which is the radius, with 15 centimeters. The exact answer to this is 4,500 pi, but we want it correct to 4 significant figures, so we need to convert it to an actual number, then round it to 4 significant figures to show that it's 14,140. B1. The sphere is placed inside an empty cylindrical tank of radius 25 centimeters and height 60 centimeters. The tank is filled with water. Calculate the volume of water needed to fill the tank. The volume of the water would be the volume of the cylindrical tank minus the volume of the sphere, which you already got from part A. So all we really need to do for this question is find the volume of the cylindrical tank. A cylinder is a prism, just with a cross-sectional area of a circle. So the volume of a prism is cross-sectional area multiplied by length. In this case, the cross-sectional area is a circle with radius 25. So the cross-sectional area is pi r squared, where r is 25. And then we need to multiply it by the length, which is 60 centimeters. And we get 37,500 pi for the volume of the cylinder, and we need to minus it with the volume of the sphere. If you want a more accurate answer, then we should be using the exact volume of the sphere, which is 4,500 pi. So we have 37,500 pi minus 4,500 pi, which is 33,000 pi. In terms of numbers, this is 103,672.6. So when we answer it, we will answer to 3 significant figures whenever we have to round something. So it's 104,000 to 3 significant figures. The sphere is removed from the tank. Calculate the depth d of the water in the tank. The shaded volume in the diagram is just the volume of water, which we already got from part 1, which is 104,000 centimeters cubed, or the exact answer is 33,000 pi centimeters cubed. This means that the volume of the shaded cylinder in the diagram, which is cross-sectional area multiplied by length, should equal 33,000 pi. And the cross-sectional area is just the same as in part 1 because the radius is still the same. So the cross-sectional area is pi r squared, where r equals 25, and the length is equal to d. So now we have set up an equation that involves d, so we can simplify this into 625 pi d equals 33,000 pi. And all we need to do after this is solve for d, or make d the subject of the formula to find out the value of d. C. The diagram below shows a solid circular cone and a solid sphere. The cone has a radius 5x centimeters and height 12x centimeters. The sphere has radius r centimeters. The cone has the same total surface area as the sphere. Show that r squared equals 45 divided by 2x squared. If the cone has the same total surface area as the sphere, then the surface area of the cone equals the surface area of the sphere. And if we can write an expression for this equation in terms of x and r, we should be able to simplify it into r squared equals 45 divided by 2x squared. The equation or the formula for the surface area of a sphere is given right here, where surface area equals 4 pi r squared for radius r. In this case, our radius is r, so the surface area of our sphere is 4 pi r squared. For the surface area of the cone, however, we have two parts to this. The surface area of the cone is equal to the area of the circular base plus the curved surface area that goes around the cone on top. The area of the circular base can be calculated from pi r squared, where r is the radius of the circle. And the formula for the curved surface area of the cone is given in the question as pi rl, where r is the radius of the circular base and l is the slant height of the cone. The r for the circular base is 5x. The r for the curved surface is also 5x. However, we don't have a value for l, which is the slant height, just yet. Therefore, we need to come up with a way to calculate the value of l in terms of x. The inside of the cone can be drawn as a right-angled triangle down the middle of the cone, where the hypotenuse of this right-angled triangle is equal to l, or our slant height, and the other two sides are equal to 5x and 12x. So since this is a right-angled triangle, we can use Pythagoras to find l in terms of x. Using Pythagoras, we have 5x squared plus 12x squared equals l squared. Then we can rearrange to make l the subject of the formula. And eventually we will get l equals 13x. So now that we have r and l, we can substitute these values into our expression for the total surface area of the cone. And since the surface area of the cone equals the surface area of the sphere, we can write the expression we have for the surface area of the cone equals the expression we have for the surface area of the sphere. Now, our expression is in terms of x, pi, and r. And if you look at the expression that we want to rearrange it into, it's r squared equals something, or r squared is the subject of the formula. So we should be trying to rearrange our expression so that r squared is the subject of the formula. And we have 45x squared divided by 2 equals r squared, which is the same thing as r squared equals 45x squared divided by 2.